Okay, today we're going to talk about the different ways of representing organic structures. The most basic way we've talked about before, and that's using a Lewis structure diagram. So if we start with a simple molecular formula, something like C3H8, we can draw out the Lewis structure for this. By drawing out all the carbon atoms, we can do a Lewis dot structure where we show the valence electrons around each of our atoms. So here we're going to put 3 carbons in a row, so 4 valence electrons around carbon. We'll add our next carbon in the chain. So we'll form a bond between those 2 carbons, so we'll share a pair of electrons there, and we'll put our 3rd carbon in a chain that way. So now we have 3 carbons in a row, 2 carbon-carbon bonds. And now we can add in our hydrogens, so we have 8 hydrogens. If you count up the unpaired electrons around our Lewis structure here, we have 1, 2, 3, 4, 5, 6, 7, 8. So we can pair those up and form bonds to hydrogen. All right, so this is our Lewis dot structure where we show every electron. We can convert this into a line bond structure by replacing each pair of electrons with a bond. And as you can see, drawing out all the carbons and all the hydrogens gets quite tedious, even for a very small molecule. So when we go to larger and larger molecules, we're going to need an easier way of drawing out our organic structures. So now we're going to introduce something called a line bond structure. So here, we're going to simplify our Lewis structure by omitting all the carbons and all the hydrogens. And we're only going to show the carbon-carbon bonds. So in the case of our C3H8, which is propane, what we're going to do instead is we're just going to show the carbon-carbon bonds. And so when we do this, we're going to show a line bond structure that looks like this. So the first rule in drawing a line bond structure is we're going to omit all carbon and hydrogens. Right? We're going to replace them with just the carbon-carbon bonds. Right? So our carbon atoms are at the ends and at any of these joints. So in our structure for propane here, we have a carbon here, we have a carbon in the middle, and we have a carbon right here. What we like to do when we draw line bond structures is to use a staggered way of drawing this. So you can see we have about 120 degrees between our bond angles here. Right? We want to try and do that. We don't want to crimp them too much. We don't want to open them up too much. We want to show this staggered structure. Okay? When we draw a line bond structure, we're implying a lot of things. We're implying that each carbon has 4 bonds. So in this structure here, we only see the carbon-carbon bonds. Everything else that's omitted is the carbon-hydrogen bonds. So at this carbon on the end here, while it only has 1 carbon-carbon bond represented, this implies that there are 3 hydrogens at this position. On this end, same thing. We have 1 carbon-carbon bond illustrated, so there will be 3 carbon-hydrogen bonds at this position. The carbon in the middle, we have a carbon-carbon bond going one way, we have a carbon-carbon bond going the other way, so that means there's only 2 hydrogens at this position. So we compare to our Lewis structure down below, our end carbons both have 3 hydrogens, and our carbon in the middle has 2. Okay? So line bond structures are fairly simple for just a hydrocarbon, but when we start introducing other elements, we want to draw those out. We can't imply that those are there. So if you have an oxygen, you have a sulfur, you have a nitrogen, these are going to be always drawn out in your line bond structure. There's no way to sort of imply that those are there. Okay? And these other elements other than hydrogen and carbon, we call these heteroatoms. So anything other than carbon or hydrogen, we're calling heteroatoms. Okay? The sort of exception to this, of these rules above, is that when you have a hydrogen that is making a bond to a heteroatom, we're going to always draw that out. Okay, so for an example of this, let's go ahead and draw out the line bond structure for ethanol. And ethanol has a molecular formula of C2H6O. Okay, so in ethanol, we are going to have one carbon bound to another carbon, and that second carbon will have a bond to oxygen. All right? So here's our starting line bond structure. This carbon here has 1, 2, 3 hydrogens on it to make a total of 4 bonds to carbon. Our center carbon here has a bond to carbon, a bond to oxygen, and so 2 hydrogen bonds are there. Oxygen, being in group 6 on the periodic table, can form 2 bonds. So it's also going to have a pair, 2 lone pairs present. And so here we want to draw in our hydrogen because we have 1, 2, 3, 4, 5. We need to put in 6 into our final structure. So we need to draw in our hydrogen here. And so very often we ignore the bond between the O and the H. So we just draw the H right next to the oxygen. Okay? So this is the line bond structure. There's a last commonly used way of representing organic structures, and that's the condensed structure. So condensed structure, it looks more like a molecular formula. So here we have ethanol, which is C2H6O. There's really no structural information in this molecular formula. We don't know what has a bond to what. But if we look at our ethanol molecule, we can sort of look at each atom in the chain and figure out what is attached to what. So if we start on the left side, we have a carbon atom here. This carbon has 3 hydrogens on it. So in condensed structure, we would draw that out as CH3. So this CH3 unit is right here. This CH3 unit is attached to this carbon here. This carbon is a CH2 unit. So in the condensed structure, our CH3 has a bond to CH2. Okay? And finally, in our ethanol molecule, we end with an OH. So in the end of our condensed structure, we will finally draw in our OH here. So here in the condensed structure, you can see there's a little bit more structural information. We have a CH3 that has a bond to a CH2 that has a bond to an OH. It's still easier just to draw it out for simplicity's sake, but very often when you're reading the book, you're going to see condensed structures like this, and you're going to want to be able to convert those into line bond structures. Also important when you're getting started is to always remember what carbons have how many hydrogens. So it's also, so when you're first getting started, it's perfectly fine to go ahead and draw in your hydrogens as needed, just as a reminder as you start getting familiar with line bond structures.